a lot of the graphing calculator skills. So if you're comfortable with your graphing calculator, awesome. If you're not, I'll try to teach you a couple of the pieces. And there's a handful of ways we can solve for systems of equations using our calculator. So the first one, we're just going to take a look at, here's an equation set up. How could I do that by solving a system of equations? And so the first thing we would take a look at is, if I see something set equal to something, how can I plug those in as two different equations in the calculator? Anybody got an idea? TJ.
Use different y equals.
So what would your first y equal be?
Negative 2x plus 1.
Good. So I can take one side of that equation and I can call that my y1. Okay, when you set that in your calculator. So your y2 would then be?
2 open parentheses x minus 3 minus 1.
Excellent. So the other side of the equal sign there can be our second y equals equation. Okay? And then essentially if we're doing this by hand, it's just substitution method, and we substitute one of these y's in for the other y, and then we have a single variable equation where we're solving for x. So what you can do is take these two equations, plug them into your calculator. This over. Okay, so you'll end up with a y equals, plug in that negative 2x plus 1, plug in the 2 times x minus 3 minus 1, and then we can ignore my third equation for just a second. That's going to be the next example we do. Okay. So when you go to graph that, you'll see you have two lines that intersect. And so if we're thinking visually what's going on, the solution to this system of equations is going to be where those two intersect. Okay, that's what we're used to seeing. And so if I were to, if I wanted to find that calculation, we can let the calculator do a majority of this work for us. So you can go to second, trace, which is calculate. And then you can go down to the intersection, and it'll actually find the intersection for you. So the fifth option is intersect. It'll ask you 3 questions. First curve, second curve, and a guess. Since I only have 2 curves, I'll say yes on the first curve. It'll jump to the second one. We'll say yes again. And then the guess is more if you have multiple intersection points. In this case, because they're linear equations, there is only one intersection point. And you can say, yep, that's my guess. And it'll find that intersection point for you. So in this case, we're able to figure out that x equals 2, y equals negative 3. So I have the solution of that coordinate point 2, negative 3. And the calculator did all that work for us. Okay? If we had done it by hand, you would have had to isolate your variables here, moved everything over, solve for x, and then resubstitute x in, and we'd get the exact same situation. Okay? But the calculator did a lot of that work for you. The next type of thing we're going to see is sometimes it makes a little bit more sense to actually combine those two equations into one. So an example would be if you were running a business and you wanted to build a profit equation. Quite often you have a revenue equation where you're making money when you sell objects, and then you have the cost of selling those objects. So you have a negative cash flow piece, and you want to know, when does my company actually make money? Well, it's typically when your cost equals your revenue and then your profit is 0. And so what a lot of companies will do is they'll build a profit equation. So they'll take these same two equations, okay, so 8 and 18 and 7 and 17, they'll be the same equations, they just want us to look at them in different routes. They'll take these and they'll say, hey, take those and combine it into one equation. So let's assume this is our cost, let's assume this is our revenue, and I want to know, when is my profit 0. So we can get everything all on one side. So this becomes 2x minus 6 minus 1. I'm going to add 2x over. I'll subtract that 1 over. And so we'll have 0 equals. So essentially, when my profit equals 0, my revenue plus my cost, or minus cost, so to speak, we think of that, this is a negative. When will this equal 0 will be my break-even point. So minus 7 minus 1 more, so minus 8. So now I can say I have one equation 4x minus 8 when I combine those two together. Does that kind of make sense? I would just put those together. Their intersection point is going to be when the combined equation equals 0. So when I go back to my calculator here, we can grab a third equation. I'm going to turn that back on. And what we'll notice is when that third equation comes in, there's something kind of cool that happens. We see that our intersection point is in the exact same x value as where our x-intercept is. So when y is 0, we find an x-intercept, those are at the exact same point, which is kind of what we were hoping was going to happen. My break-even point is that intersection point, or when I combine it into 1, my profit is 0. Does that kind of make sense? So you can have your calculator also calculate this intersection point for you if you want. And so if we were to go to second calculate, or second trace, so calculate, you can find the 0 of a function, or your x-intercepts, so the second option here. And then you got to make sure you're on the right curve, so I'm going to press up until I'm on there. So you'll see it's on y3 right now, which this is my 4x minus 8. That's the curve I want. So my left bound, I got to go left of the x-intercept. Then it'll ask you another question, find the right bound, so get on the right side of your x-intercept. And then it'll ask for a guess, so go somewhere in between your bounds, and it'll solve for it. It'll say, hey, x equals 2 is your x-intercept. So when y is 0, x is 2. And this should hopefully make sense for us because it ends up being the exact same value we found earlier. So my coordinate point for this is when x equals 2. And I can plug that back into either of my equations, and we'll see that our y again is going to equal -30. So if I had that back in the original equation. So this tells me that if I'm selling widgets or whatever, when I sell 2 of them, I break even. If I sell more than 3, I'm going to start making money. If I only sell 1 or 0, I'm losing money. Okay, so you can use that as like a profit equation if we had that situation. All right, the next thing we're going to see is, again, the exact same equations, because we're not trying to test the algebra skills right now. We're just kind of looking at how do we read and interpret these kinds of things, and what do they mean to us. 28 is going to be the exact same equations. Okay? But now when we take a look at this, we want to solve the following inequalities using this intersection method. Which we've already used that method on the calculator. We go to that intersection, solves for it. It tells us that in this graph, we ended up with that shape with that shape. Okay, and our intersection point we already identified was this 2, -3. Okay. So what's more important is we want to think about how can I read this and how do I solve this. So if we're still thinking about this as that profit situation, we could say something like my green is going to be my cost and my purple is going to be profit. And so for the sake of shorthand, let's call the green one some f of x, and let's call the purple one some g of x. Okay, so they're 2 different functions. I want to know when is my function of x greater than my g of x, that other function of x. And so if I grab like a vertical line, this can help sometimes. Basically, as I go along there, which graph is above which graph as my x's move? So in this case, which is above, green or purple? Green. So at the moment, my g of x, or my f of x, is greater than this g of x. And color coordinating wise, let me switch this really quick. Okay. So I know that the green is greater than the purple. And so that is true all the way up until I hit my intersection point, which is where they are equal to each other, where they break even. And then as I continue further, that relationship flip-flops and we see the purple is above the green, or my g of x is actually greater than f of x. And so in that situation, I see for all these values where x, is less than our intersection point, so everything less than 2, I know that my f of x is greater. So my expenses are greater than my revenue, if we keep that same business analogy. So I'm not making money until I get over there. So for all my x's less than 2, my expenses are greater than my revenue. Does that make sense? So this is going to be the same graphing. Now we're just trying to interpret it slightly different. And when is this function, that function, greater than this function? And it's when it's above that as we move left to right and look at it. Okay? Kind of make sense? The last piece we're going to take a look at is solving literal equations. So basically we're doing algebra without numbers. And so we'll see stuff like this, where we'll have some equation that's solved in terms of something that's not the most important to us. So maybe this was an equation where I wanted to see what P was, and then eventually we're like, well, maybe I know what I want P to be, but we're going to figure out what is C going to equal when I change M and P. So maybe we want to solve for C. So similar example here, I want to solve this for P. In order to do so, we got to get P by itself, but we've got P in 2 locations. So how do I get the P into one spot, or how do I isolate it kind of? Anybody remember how to do that step? Think about what we were doing earlier with like x squareds and x's. What did we try doing? Kind of. If I had something like that test question, right, that was like x squared minus 4x, and we were trying to solve for x, we had to factor out the x. Excellent. So the exact same situation here. I've got a p minus a pd. What can I pull out? I can pull out that p. So s is going to equal p, and when I factor out a p, we're left with 1 minus d. Okay. Why is it a 1? Because p times 1 is p. Excellent. Or if we think about the reverse order we did, when I pull out a p, p divided by p is 1. Okay. So we got to make sure we keep that 1 there, so when we distribute back in, we're the same. Now 1 minus d is just this number. Okay. It's just a coefficient in front of p. So to get p by itself, we just have to divide both sides. So s over 1 minus d is going to equal p. And now p is all by itself. Okay? So it's basically algebra. We just don't have numbers. We're dealing with letters. So if it messes with you, think about p being the only variable, and then in your mind try to make everything else numbers. You just can't combine like terms or anything because they're different. Okay? So there's a little bit less simplification going on since there's not numbers. Cool?